In this video, let's solve some recursive simplification. So compute the value of A14 given the value function. This otherwise known as an Ackermann function. So y plus 1 if x is 0, and then ax minus 1 for y equals 0, and ax minus 1 axy minus 1 for if it's otherwise. So here the given is 1 and 4, so we have 1 4, and immediately 1 4 will apply this third rule, otherwise. So we're going to subtract 1 and then apply the second function here. So this will become a 0 for x minus 1, and then a of x, a of 1, y minus 1, so 3. And this function a13 will apply the third case as well. So this will be 1 minus 1, so it will become a, so 1 minus 1 0, and a, so 1, y minus 1, so that is 2. This function will again apply the third case. So the third case is minus 1, so this will become a 0 and a 1, and then y minus 1, so this will be 1 1. Okay, in the same manner this will apply the third case, otherwise. So this will be a0 and this would be a of 1, y minus 1, so 1 0. In this case it's already 1 0, so the y is already 0, so it will apply now the second case, case 2, where it will translate into a x minus 1, so this will be 0 and 1. Here this function now will apply the first case, where you have x as 0, so this will be now interpreted as y plus 1, or this function is equals to 1 plus 1, y plus 1. So this is equals to 2. Now when this is equals to 2, so this is 2, so this function is 0 2, and 0 2 will evaluate by the first case, so first case again, and this will evaluate to y plus 1, so this will evaluate to 2 plus 1 or 3. And this function here will evaluate to, so this is already 3, so 0 3, that will be again the first scenario, y plus 1, so this will be 3 plus 1 and evaluate to 4. And if this is 4 now, 0 4, in the same manner this will be 4 plus 1. Again, we're applying the first case. We have 5. Finally, when we have 5, 0, 5, we are going to apply 5 plus 1. Again, applying the first case. Therefore, you have 6. So, the final value of A14 basically is 6. And so this is the final answer. A14 is equals to 6. Let's try another Ackermann problem. Say, compute the value of A21 given the function axy defined for integers x and y. So same function, only different values for x and y. So the x and y now we have as 2 and 1. So this, we are computing this function, and first scenario is again the third case. This is otherwise, so 2, 1, and in that case we are expecting to have x minus 1, so A1 partnered with A and say x, y minus 1, so this would be 0. And simplify this function, we have the y equals 0. So this is the second scenario. For the second scenario, we'll have ax minus 1, so that is A1 and 1. So this is now A11. So with this A11, we are now back at the third case. So back at the third case, we have A0 partnered with A1 and 0. Okay, so A10, we are back to case 2. So case 2 again, y is 0, and in that case we're going to simplify this as A0 1. 0 1, we are now back, or we are now going at the first case where x is 0. So in that case we will have now a value which is y plus 1. So this is now equals to, evaluate to y plus 1, or specifically the y here will be 1. Thus this is equals to 2. So when this is 2, this function here is 0, 2, and 0, 2 will choose again the first case, y plus 1. So this will be 2 plus 1 equals to 3. And when that is 3, therefore this A11 is equals to 3. And the same manner, A20 will be equals to 3 as well. Therefore, this original problem is equivalent to A13. So A13 will again apply to the third case. So this one, third case. So solving for the third case of A13, we'll have, so this equivalent to A0 and then A1 and y minus 1, so this is 1, 2. So again we will evaluate A12, so this will apply case 3, again case 3 for otherwise. So we have a 0 and a 1 1. Okay, so finally this will apply again case 3. So a11 will become a 0, a 0, or a10 now, 10. So a10 will apply now case 2 where y is 0. So similar with the previous case here. So a10 is equivalent to a01. So this is a01, and we already know what that is. 01 will result to 2 because this is 1 plus 1. So when this is 2, we will have again go back to 1 0. So this is 2, and this will be 0 2. So 0 2 will be 2 plus 1, and that is equals to 3. So when this is a11 will be 3, we are now solving for a03, and again that will be 3 plus 1. Again, we are already applying the base scenario when you have y plus 1. So 3 plus 1, therefore this a0, so this is a12, this is actually 4. So finally you have a0 4, and what is that? That is equivalent to 4 plus 1. Thus the answer for a13 is basically equal to 5. Thus the final answer, a21 is equals to 5. And basically that's it.